Today's lesson is on greatest common factor. First, we'll look at some vocabulary. Common factors are factors that are shared by two or more numbers. For the greatest common factor, we also can say this as GCF. That would be the greatest of the common factors. Now we're going to find the GCF, which is the greatest common factor, using lists of numbers. So we're going to find the GCF using a list of factors. So for our first problem, we have 8 and 36. So our first step is to write the factors for 8, and then also to write the factors for 36. So the factors for 8 would be 1, 2, 4, and 8. We get this because 1 times 8 is 8, and 2 times 4 is also 8. There are no other numbers that we can multiply together to get 8. Now we need to list the factors for 36. So for 36, we would have 1 and 36, and that would give us 1 times 36 is 36. And then 2 times 18 equals 36. 3 times 12 equals 36. 4 times 9 equals 36. And then 6 times 6 equals 36. We don't have to write the 6 two times, we can just write it once in our list of numbers. Now we need to find the greatest common factor. So we're looking for the largest number that appears in both lists. You will notice that a 1 is in both lists, a 2 is in both lists, and a 4 is in both lists. So 1, 2, and 4 are our common factors. Our greatest common factor would be the 4. So that would be our GCF. Our greatest common factor equals 4. Now for number 2, we're going to do the same thing, but this time we have 3 numbers. So we want to find the greatest common factor that appears in all 3 of our lists. So we're going to look at 14, 28, and 49. So first we'll list our factors for 14. So for 14 we have 1, 2, 7, and 14, because 1 times 14 is 14, and 2 times 7 equals 14. Now we'll look at our list for 28. For 28 we would have 1 times 28, and that equals 28. 2 times 14 equals 28, and 4 times 7 equals 28. And now we need to look at our list for 49. For 49, we have 1 times 49 equals 49, and then 7 times 7 equals 49. Again, we just list that 7 one time. Now we need to look for our greatest common factor. All 3 lists have a 1. Only the first 2 lists have a 2, so that would not be a common factor. Now all 3 lists also have a 7. That is the largest number that appears in all 3 lists. So 1 and 7 would be our common factors. 7 would be our greatest common factor, which would be our GCF. So our greatest common factor equals 7. Now we're going to find the greatest common factor, or GCF, using prime factorization. So for number 3, our 2 numbers are 20 and 45. So first we're going to make factor trees for 20 and 45. So for 20, I need to come up with 2 numbers that I can multiply together to get 20. I could do 2 times 10, or I could do 4 times 5. It doesn't matter, I can just choose one or the other. So let's go ahead and do 4 times 5. 4 is not prime, so I need to come up with 2 numbers that I can multiply together to get 4, and that would be 2 times 2. 2 is prime, so I'm going to go ahead and circle the 2's. That means that I'm finished with those 2's. The only thing I could branch off from those 2's would be 1 times 2, and we don't need to go that far with using a 1 because that doesn't help us. 5 is prime, so I will stop with 5 on that one. So for 20, I have 2 times 2 times 5, and that equals 20. Now I'll do the same thing for 45. For 45, I could say 5 times 9. 5 is prime, so I do not need to branch that one off anymore. And 9 could break down to 3 times 3. 3 is prime, so I'm finished with my 3's. So 45 would be 3 times 3 times 5. So again, 20 was 2 times 2 times 5, and 45 was 3 times 3 times 5. Now I need to see what number appears in both of my lists. 2 only appears for 20, and 3 only appears for 45. But you'll notice that 5 appears in both of the lists. So my greatest common factor is 5, or my GCF would equal 5. Now we're going to do the same thing again, except for this time our numbers will be 12 and 56. So we're going to find the greatest common factor using prime factorization for 12 and 56. So first we'll make our factor trees for 12 and 56. 12, we could say 2 times 6, we could say 3 times 4, so I'll just go ahead and do 3 times 4. 3 is prime, so I am finished with the 3, but 4 is not prime, so I can go ahead and branch that off and say that 4 is 2 times 2. Now I have my prime numbers that make 12. 2 times 2 times 3. Now I need to do the same thing with 56. For 56, I can do 7 times 8, and that gives me 56. 7 is prime, so I will circle it. That tells me I'm finished with 7, but I need to go ahead and work with 8. 8 is not prime, so I need to go ahead and branch it off. 8 could be 2 times 4. 2 is prime, so I'm finished with the 2, but 4 is not prime. So again, I need to go ahead and break down that 4 a little bit more. 4 would be 2 times 2. 2 is prime, so I'm going to go ahead and circle it, and now I have everything circled that I need. 2 times 2 times 2 times 7. So again, my prime factorization for 12 was 2 times 2 times 3, and my prime factorization for 56 was 2 times 2 times 2 times 7. Now I need to see what appears in both of my lists. You can see that I have a 2 that appears in both lists. I also have another 2 that appears in both lists. I do not have anything to match up with the 3 that's in the 12, and I do not have anything to match up with the 2 or the 7 that are left for 56. So I have a set of 2 circled and a second set of 2 circled. So now this time to get my answer, I will multiply 2 times 2. And 2 times 2 is 4. So my greatest common factor equals 4.